Assalamu alaikum students. Lastly, we have read about the nuclear energy, and finally we said that nuclear energy is the energy obtained by conversion of nuclear matter or nuclear mass, that very mass which is converted into energy, and that mass is from the nucleus of an atom. That's called as nuclear energy. The nuclear energy that we get is available. We are going to get it through two processes. One is called as a nuclear fission, and this is called as nuclear fusion. So what happens in fission? Fission is simply the splitting of heavy nucleus. As here we're having a heavy nucleus which is uranium 92 235. It is bombarded by a thermal neutron. You have to understand, you have to remember that thermal neutron is a neutron whose energy is very small, of the order of 0.025 electron volt. Thermal neutron, जिसको हमने नाम दे दिया है. Once it is bombarded on this very heavy nucleus, there can be one process which is called as radiative capture. As I told you that there will be excitation energy, but that is not going to favor the electrostatic repulsive force. Hence, there will not be splitting. If that is going to favor electrostatic repulsion force, then it is there going to be splitting, and there will be nuclear fission. In nuclear fission, what happens? There is production of two lighter nuclei, as here barium and krypton, being lighter as compared to the uranium. Plus, there are three thermal neutrons plus 200 million electron volt energy, and there is a mass defect of 0.215 AMU, and which provides an energy of 200 million electron volt energy. So it is all because of the mass defect. Now this very nuclear fission can be a, actually there you should have the concept of nuclear chain reaction chain reaction. What is actually chain reaction is a reaction in which one nuclear transformation is capable of starting a chain of it. What I am saying, listen. What happens here we are having a thermal neutron. It is bombarded on what? It is bombarded on uranium 92 235. It becomes as uranium 92 236. Now what happens? There is barium, there is krypton, this is barium, this is krypton, and there are three thermal neutrons plus the energy. Now we don't, once we are having a sample of uranium, we are not having only one atom, we are having a large number of atoms. So the neutron here or here, they are going, this is going to bombard with another barrier, here, what I mean to say, this uranium. Then there will be barium krypton, here will be again barium krypton, here will be again barium krypton. So again, one is this is on a single atom. As we are having a sample, there are huge number of atoms. So the neutron is produced here, gets again bombarded on one another atom of uranium, here again another of uranium, here again another of uranium. So there will be barium krypton plus three neutrons, barium krypton plus three neutrons. So the process is going to continue, and there will be again, here was production of 200 million electron volt, here it will be 200, so here will be 600. So then the process continues, and this very process called as chain reaction. But this very process called as uncontrolled chain reaction. Why uncontrolled? Because uncontrolled chain reaction is the one in which we cannot control the what energy content. Carefully, first in the first step there was an energy of 200 million electron volt. Now when the three neutrons got bombarded on three atoms, so here it will be 200, here it will be 200, here it will be 200. So in the second stage we will get a 600 energy, and in the third stage we will get much more energy than that. So this very process called as uncontrolled chain reaction or uncontrolled chain reaction. Uncontrolled chain reaction or simply uncontrolled fission, because we cannot control here the energy content at every stage. This is called as uncontrolled chain reaction or uncontrolled fission. The reaction in which energy at every stage changes. Or you can give another difference, the reaction in which the number of neutrons that every stage change, because first we are having the one neutron, then we are having three, then we will be having here three, here three, here three. That will be nine neutrons in that will be third stage. So there will be a huge amount of energy. So at every stage there is change in the number of neutrons. So there will be change in the energy content. Hence the energy will be produced large and large. And this uncontrolled chain reaction is principle for what? Atomic bomb. Atomic bomb. Atomic bomb is the principle of atomic bomb is uncontrolled chain reaction. Because in atomic bomb the purpose is once you are going to drop it the huge amount of energy. You don't require a fixed amount of energy to be come out from it. So uncontrolled energy, huge amount of energy is produced once you are having uncontrolled chain reaction, and that is the principle of atomic bomb. On the other hand, we can have a controlled chain reaction. Now the word you will get it, controlled chain reaction. Controlled chain reaction means that once we are having this very as a nuclear process, there we are having three neutrons. Once this very three neutrons, they are going to produce 600 million electron volt energy. But if somehow by some mechanism, if this and this neutron is absorbed, then there only remains one thermal neutron. So it is going to hit only one uranium atom. So again there will be barium krypton plus three neutrons. Those in the three neutrons, two will be again absorbed by some mechanism. So at every stage, so reaction in which fixed amount of energy is produced at every stage. Or you can say like this, where there is a fixed number of neutrons emitted at every stage, that is called as what? That is called as controlled chain reaction. And this controlled chain reaction is principle for nuclear reactor. Because in nuclear reactor, we are of the opinion that the nuclear energy that we got, that is going to produce electricity, and electricity is for the peaceful purposes. So we should have there a controlled amount of energy, and that is only possible once we are having a fixed amount of energy at every stage, and that is only possible, fixed amount of energy only possible once we are having the fixed amount of neutrons coming at every stage. Because if there is not increase in the neutron number, so there will not be increase in the energy released at every stage. That means there is a fixed amount of energy, hence you can say there is a control. That reaction is called as controlled chain reaction. Now there is another one process which is called as a nuclear fusion. What is nuclear fusion? Nuclear fusion is opposite of nuclear fission. Nuclear fusion simply means fuse. Fuse means to combine. When combination of two lighter nuclei to form an intermediate nuclei. Because as you we are aware, the lighter nuclei, you can take the hydrogen, that is very much unstable. But once that very hydrogen is going to combine, as we are having in the as nuclear fusion is a very difficult process, but in laboratory we're having hydrogen 1 2 plus hydrogen 1 2, that's deuterium. It uses hydrogen 1 3 tritium plus hydrogen 1 1 plus 4 million electron volt. In the second stage, what happens? It will be hydrogen 1 3 plus hydrogen 1 2. It will be helium 2 4 plus neutron plus 17.6 million electron volt energy. So there is combination in nuclear fusion. What actually happens? There is combination of two lighter nuclei to form an intermediate one. But this nuclear fusion is a very much difficult process. It is not as such that two nuclei are brought and they are going to combine. No, they are not going to combine, sir. Because once we are having the two nuclei, we are talking of the nuclei, this nuclei hydrogen and this nuclei of hydrogen, they are having the positive charge. Once they are going to brought to each other, they are going to exert a force of repulsion. This is going to go like this is going to exert. They are going to move from each other because of their positive charge. So, in order to make them combine, they require a large amount of kinetic energy, and that large amount of kinetic energy is possible only on the having large amount of temperature. So nuclear fusion process is a difficult process because two lighter nuclei are having the positive charge. Two nuclei, once they are going to come closer to each other, they are going to exert a force of repulsion. So they cannot combine. So in order to combine, they require a huge amount of kinetic energy, large amount of kinetic energy, which is possible only at high temperature. So once you are having a large amount of temperature to those very nuclei, then they are going to combine, and that's why it is called as thermonuclear process. There is involvement of large amount of temperature, and of the order of 10 raised power 7 to 10 raised power 8 to 10 Kelvin temperature is requirement, so that you can have what you can have the combination of two lighter nuclei. And uncontrolled nuclear fusion is principle of hydrogen bomb. You might have heard about the hydrogen bomb. Hydrogen bomb is formed once there is a nuclear fusion, and that is only possible once there is uncontrolled nuclear fusion, and there is large amount of energy. Actually, once we have to initiate a hydrogen bomb, where we have to first provide energy of the order of 10 raised power 7 to 10 raised power 8. So once we are going to provide this very much energy, you might be you might not think that this might be an endothermic process, but this is an exothermic process because the energy released in nuclear fusion is much more large as compared to we are providing it. The energy we are providing it is only because the nuclei fuse. Why? In order to overcome the force of repulsion, they can only fuse when they have large amount of kinetic energy. It's only possible at higher temperature. So you have to remember what is nuclear fusion, what is nuclear fission. Although the energy, if you are going to see, this is 17 plus 4, let it be 20, 21. You are seeing here in the first fission, it was 200 million electron volt, but here it is only 21. You might thought nuclear fission is much more dangerous because there is 200 million electron volt, but nuclear fusion is more dangerous because the mass energy released per unit mass here in the fusion, it is large as compared to the fission. Once again, you have to remember it. Nuclear fusion is a dangerous process because energy released per unit mass in case of fusion is large as compared to fission. This all regarding nuclear fission and fusion. Tomorrow will be with another topic. Till then, Allah Hafiz.